My name is Bill Halliday. I work for Wildlife Conservation Society Canada, and I'm also an adjunct professor at the University of Victoria. Today, I'll be talking to you about estimating the exposure of beluga and bowhead whales to ship noise in the Pacific Arctic. Before I get going, I have a number of co-authors here listed at the bottom of the screen who were just instrumental in this study. Without them, I wouldn't have been able to do certain analyses, or I wouldn't have even had access to very important data sets. So thank you to all of these authors. The Arctic is changing. The physical environment is changing simply because of climate change causing a loss of sea ice. That's having cascading effects throughout the ecosystem, though. Oceanographic properties are changing, habitat characteristics are changing, and this is impacting marine life in a variety of different ways. The loss of sea ice is also allowing for increased access for human activities. Shown here on the right is ship traffic through the Canadian Arctic, and you can see that over the last 20 years or so, there's been a drastic increase in ship traffic through the Canadian Arctic compared to the baseline period. And that applies throughout much of the Arctic as well. It's not just a Canadian thing. With that increased ship traffic comes increased underwater noise. Ship traffic is noisy, and that noise negatively impacts marine life. Underwater noise can cause acoustic masking, where animals have difficulty communicating with one another or listening to important signals, simply because there's so much noise in the background that they can't hear what they're trying to hear. Underwater noise can cause behavioral disturbance, where the animal stops doing what it would have originally been doing simply because of the noise, and it changes its behavior in response to the noise. Underwater noise can also cause hearing damage or even death. However, the first two most important impacts of ship noise are acoustic masking and behavioral disturbance. So we have some basic understanding of the impacts of noise on marine mammals, like I was talking about in the previous slide. However, there's little information available on the actual exposure of Arctic whales to ships or ship noise, with only a handful of studies trying to get at this question. So in this project, we're specifically interested in examining patterns in ship noise in the Beaufort and Chukchi Seas, and how this overlapped with beluga and bowhead whale distribution. So here we're talking about eastern Beaufort Sea belugas, and then the Bering Chukchi Beaufort stock of bowhead whales. So first, starting with looking at the distribution of these whales, we used satellite telemetry data for both species. For the bowheads, we used satellite telemetry data from 2006 to 2018. From that data, we modeled daily positions and then calculated the monthly distribution as their 50% utilization distribution. And this series of maps, you can see how that changed between July and October, with in July and August, a fairly good concentration of whales in the Canadian Arctic, and then September happens and the migration begins, and whales start to spread out across the Beaufort Sea into Alaska. And then October, they're centered around the Chukchi Sea, as well as a little bit of the Western Beaufort Sea. For beluga whales, the data were collected in 93 to 97, and then again in 2004 to 2005. We use the same general methodology that we did with bowheads. And then looking at their monthly distribution, it's also somewhat similar to the bowheads in the Canadian Arctic in July and August, and then shifting into Alaska in September. But it is much more concentrated in the Chukchi Sea in October. So those are our whale distributions. The next step was to actually model noise. So to do this, we did acoustic propagation modeling. First, we looked at just generally how noise spreads in the different parts of this region. And this is what you can see up in this figure here. The bright red colors are louder noises close to the ship track. The ship track is that dark red line. And then you can see in the different areas in the Beaufort Sea, in the Canadian Arctic, in the Amundsen Gulf, and then in the Chukchi Sea, you can see how noise spreads. And you can see that it doesn't seem to spread very far in the Chukchi Sea, whereas it reaches much further in the Beaufort. And that has a lot to do with the bathymetry in the region, how deep the water is. So we took these general trends together with some estimated source levels, which were measured by the Port of Vancouver's ECHO program. So the source level is how loud individual ships are. And we applied these trends to ship tracks measured from automatic identification system, and we estimated a noise footprint around individual ships. We then took all of the noise footprints from all of the ships within a month of each year and combined them together to assess how often the 120 decibel threshold for behavioral disturbance was surpassed. And that 120 decibel threshold is a threshold that NOAA uses for behavioral disturbance. So effectively, this is a count of the number of times a disturbance event might happen in a given grid cell. We then overlaid the monthly marine mammal distribution, and the result that we get is this figure here on the right, with monthly noise and monthly distribution of whales in July through October of the years 2015, 2016, and 2017. I'll zoom in specifically on 2017 here just to talk about some general trends. So first off, July is a low shipping month, which means there's low ship noise. And more importantly, the whales are in the Canadian Arctic where there's even less ship traffic compared to the Alaskan and Russian Arctic. So there's only 2 to 3 ships per year that are overlapping with these whale areas in the month of July. Ship traffic increases, however, in August and September and October, so we get increased noise exposure. And as the whale distribution moves into the Alaskan Arctic, moves into the Western Beaufort Sea and into the Chukchi Sea, especially in September and October, we get increased noise disturbance events, potential noise disturbance events, simply because the whales are moving to where the ships are. And as those whale distributions get closer and closer to Bering Strait along the coastline, they tend to get more noise disturbance events. So this is effectively the end result of this modeling study. And with this, we can identify hotspots of where whales are potentially overlapping with more ships and they're getting exposed to more ship noise. And it's going to let us make management recommendations, like identifying areas where maybe we need to move ships away from this important area for bowheads. Now, that's one way to look at the exposure. That's looking at noise exposure to the entire population of whales, the entire distribution of those whales. But what about individual whales? How often are individual whales coming into contact with ships? And so that's this next part of the project, where we looked at individual whale tracks and we compared them to concurrent individual ship tracks to see how many ships they were coming into contact with. We used the same Bowhead data, so we focused on between 2012 and 2018 because that's when we had satellite AIS data available. We also had Beluga data from 2018 specifically, so we did have a new concurrent data set to use in this. And this analysis is being led by our postdoc, Morgan Martin. So just to get right into it, here's a summary table for bowheads showing the years in the rows and then different variables on the columns. So the number of tagged whales, the number of ship overlaps, where a ship was within at least 120 kilometers of the whale within a year. We picked 120 kilometers because that's effectively how far the loudest vessel might be heard if it was a very loud vessel and in deep water, but very likely it's too far for any sort of noise impact to be happening. But it still gives us an initial threshold to look at. Then we've got the closest encounter and then the average closest point of approach for all ships with all whales in that year. And so we can see that there's a bit of variability around the number of whales tagged per year between 1 and 11. And in those years where there's only a single whale tagged, those single whales still came within 120 kilometers of between 97 and 161 different ships. So that's quite a few ships that these whales are coming into contact with, even still in the Arctic. The closest point of approach was 1.2 kilometers across all of these whales tagged throughout all the years, which is fairly close given the amount of error that probably is associated with these whale data and with the ship data as well. These whales were specifically tagged with Argos tags, which have some spatial accuracy issues. So if we found that they came within 1.2 kilometers of a ship, they actually probably came maybe even closer than that. Moving over to the belugas. So the belugas, they were only tagged in a single year here. So now I'm showing you each row is an individual whale that was tagged. There are 8 whales that can tagged, and you can see one thing important come out here, and that is that 2 whales have a lot more exposure than the others. And that's because those 2 whales, which are number 4 and 5 here, the bolded ones, they tended to stay closer to the mainland coast, whereas the other 6 whales went much further offshore. So they were exposed to much fewer ships. And those whales that were exposed to more ships came closer to ships than the whales that were further offshore as well. So they claim as close as 10.3 kilometers away from the nearest ship. And you can see the average closest point of approach is actually quite far compared to the bowhead data on the previous slide. So in general, these belugas are staying further away from ships, and that might be behavioral. It might also be due to their habitat preference. So following up from this study, we'll be looking at the reactions of whales to ship noise, as well as different ways to manage and limit that exposure. And with that, thank you for listening, and I hope to get questions from you at some point.